everybody. How are you doing today? I hope you're good. To continue from where we stopped last time we are discussing the characteristics of waves. Today we are going to be looking at the properties of waves. Properties of waves. By the end of this lesson, you should be able to state and explain at least 4 properties of waves. You should be able to state and explain at least 4 properties of waves. The properties of waves we are talking about here, the properties the waves exhibit, the properties they exhibit, and these properties include the reflection, refraction, the refraction, diffraction, interference, polarization. I repeat, the properties are the reflection, refraction, diffraction, interference, and polarization. But because of want of time, we are going to be looking at the first 4. So let's start with reflection. I'm reaching out. I need you now. Reflection is the change in direction of a wavefront at an interface between 2 different media, so that the wavefront returns into the medium from which it originated. Reflection is the bouncing back of waves when it encounters a medium from another medium. We are talking about medium here. I've explained that before. The solid, the liquid, or the gaseous medium. The reflection, when a wave is moving from one medium onto another at the interface, if the wave bounces back because the interface is a reflecting surface, if the wave turns back, moves back to the original medium, this is what we call reflection. Reflection can be seen in the light waves, sound, water waves. Examples of reflection, I would like you to look at this second diagram. The second diagram here shows reflection. This is the interface. This is another medium. A medium, the interface of the medium, and this is another medium. If a wave is coming from a particular medium, I want you to look at it. A wave moving from this medium. When it touches the second medium, it reverses back to its original position. Watch it again. It returns back to its initial position. Watch it again for the last time. This is called reflection. So let us look at the second one, which is refraction. Refraction of waves involves a change in the direction of waves as they pass from one medium to another. It is the bending of the path of the waves. The bending of waves when it moves from one medium into another medium. So, which means the second medium must be a transparent medium. Transparent medium is that type of medium that a wave can pass through, something can pass through. So, if the second medium, the medium is a transparent medium, and its density is different from the density of the other medium, as waves move from a medium into another medium of different density, it bends, it changes direction. It will not continue to move in its initial direction, initial path. It will change path. The path will change, will bend. This bending is what we call refraction. Remember, refraction is bending through. It enters the second body. But reflection is bending outward. It turns back. But refraction, bending inward, bends through. Okay, let us look at this. If we have, for example, a glass, this glass is a medium, and this is air from where the light is coming from. So as this light moves from air, on reaching this interface, that is the surface that is separating this air and the glass, what happens? This light will not continue to move in its original path, original direction. Look at what happened. It changed direction. It bent. So this bending here that occurred at this surface interface is what we call refraction. I would like you to also look at what happened inside of this glass. The light moved this way. The light moved this way, but on moving out of the glass, from glass to air again, it has to bend because glass and air are of different density. Glass is denser than the air, so the light, which is a wave, bends. Another example of refraction can be seen here. For example, let's use this, maybe a water wave. This water flowing in this particular direction, this is the direction of the water. We have two media here, the white one and then this ash one. So you see, as this wave moves from the white medium, on reaching this interface, this separation, it changed direction. Look at it. Yeah, the direction of the waves changed. They bent towards the second medium. They pass through the medium because the medium is transparent in nature. So what happened here is what we call refraction. The next one we have to discuss is the diffraction. Diffraction. Diffraction is the spreading or bending of waves round barriers or obstacles or apertures or slits. The spreading of waves round barriers. If a wave encounters an obstacle, the wave will start spreading or bending round, curving, will start spreading when it passes through an aperture or a barrier or an obstacle. This is what we call diffraction, bending or the spreading of waves round obstacles. Example, look at what happened here. We have two surfaces. This is the obstacle now. Look at, we have an aperture, an opening here, slits. The wave initially is a plane wave, straight lines, but on passing through this hole, the wave can pass through this position, so the wave will have to bend, will have to like spread. The spreading that occurred here is what we call diffraction. This is diffraction. Okay? So, another example, water waves. Water flowing in this manner, as you can see, linear. This is a linear wave. The waves are just like straight lines, but on reaching this opening, this is just like a barrier or an obstacle. The wave will start to spread. Will start to spread as we have here. What happened here is what we call diffraction. The next one is interference. What is interference? Interference is a phenomenon in which two waves superimpose, or overlap to form a resultant wave, which is greater, lower, or the same amplitude as the initial. I said interference is the superimposition of two waves of equal amplitude moving in opposite direction. This will cause the two waves to overlap or superpose, forming another wave which is either greater than the initial amplitude or smaller. Interference is divided into two. We have the constructive interference and the destructive interference. What is constructive interference? Constructive interference is the interference of two or more waves of equal frequency and phase resulting to their mutual reinforcement, that is overlapping, and producing a single amplitude equal to the sum of the individual amplitudes of the waves. That is the superposition of two waves to produce a wave that is higher, that is bigger than the initial waves combined. So the wave produced, that type of interference is called constructive. When you construct a wave of higher amplitude, the wave that is bigger. For example, look at this. We have two waves here, the one yellow in color and the dark one. These two waves, as you can see the way they are moving, one is moving forward, one is moving backward. These two waves will like overlap each other, and the cause of their movement to produce this particular one bigger. This particular one, light purple shape wave. This one is the wave produced, and the wave is bigger. So what happened here is constructive interference. Let's look at the second one, destructive interference. This is the interference of two waves of equal frequency and opposite phase, resulting in their cancellation, where the negative displacement of one coincides with the positive displacement of the other. Here, the two waves combine, overlap to produce no wave. The two waves cancels each other. For example, look at what happened here. Look at the top diagram. Forget about this one here. The top diagram here presents destructive interference. We have two waves, the blue one and the red one. The movement of this wave, the overlapping of these two waves, produce the cancellation of the two waves. As you can see, to produce just a straight line, a dead wave. This is what we call destructive interference. Okay, let us look at the summary of the. Let's look at the summary of the constructive and the destructive interference. For the constructive interference, like I said, two waves combine to produce a bigger wave. Two waves moving in the same manner, the same phase. They combine together to produce a wave of higher magnitude of amplitude, a higher amplitude. For destructive interference, two waves combined in such a way that they will cancel each other. They move in opposite phase. As this one is moving from down to up, this one is moving from up to down. So they move in opposite phase, and which leads to the cancellation of the two waves, producing a dead wave. This is what we call destructive interference. Okay, so thank you very much for listening. Thank you very much for viewing. God bless you. Next time we are going to be looking at polarization of waves and the rest that comes under waves. Goodbye.
Preacher man, please help.